So let me state at the outset that I certainly make no claims to, I'm not a scientist, and I think there's often a danger of a person dabbles in another discipline. It needs to be done, first of all, with humility. Secondly, it needs to be done with a concept and a sense of a bigger picture. So certainly making no claims here at all, other than I've read somewhat, and I try to keep abreast of the some of the latest developments in this field. And I think it should interest us as intelligent, thinking human beings, as from Yidden, as religious Jews, because it has a lot of implications. So let's get started. Next week will be more based on the philosophy, and then finally the third part will be the Torah. And I've done that deliberately because we're going to move, as it were, inward, and so there should hopefully be a progression of ideas. Let's get started. So I've called this a little bit playfully free will, free won't, and that fateful lunch in Freiburg in 1964. And I'll explain as I go along what this refers to. So we are going to be dealing with what science has to tell us about free will. Now, until relatively recently, science would have had very little to tell us about the concept of bechira, about the concept of free will, because it was something that was very much the province of philosophers, theologians, religious leaders, and the Torah, of course, has a lot to say about this. It goes without saying that as far as we are concerned, bechira, free will, is one of the most important axioms that exist. If we have no free will, there is no accountability, and more than that, and this relates, I suppose, to the Derech Hashem shir of Tuesday night, purpose. And again, in philosophy, we're going to need to talk about volition and agency, but tonight we're not really going to go into that too much. So free will, what does science do? Until recently, science had pretty much nothing to tell us about it. It had nothing to do with science. However, that all changed, arguably, at a fateful lunch with two neuroscientists. One of them was a PhD, the other one was his research assistant, and they were having lunch. They both worked in the University of Freiburg in 1964, and they were perturbed. They were certainly Herr Kornhuber, who was the one that got this started, was perturbed by developments in society, and we'll talk about that a little bit. And therefore, his purpose, as he says, he writes himself. I believe he is certainly his student Dirk is still alive. Was alive last year in Vienna at the age of 81 or 82, and he said we sat down for that lunch, and the idea was that we were going to almost defend free will from the reductionists. And we'll come to that in a second. So that was the point. So they devised an experiment, which we'll come to in a minute. But before we go any further, it's always a good idea to start with a little bit of humor. And here to provide it this evening, we're going to top and tail it with humor. There'll be humor on this slide and the very last slide. But we will start with Stephen Hawking, who had an incredible, a very dry sense of humor. He was British. He says, I've noticed even people who claim everything is predestined and that we can do nothing to change it, look before they cross the road, which is an interesting point. How seriously he meant it, and what does that have to say about the different ideas about determinism, probably we will look at next week. So let's press the wrong button. Here we go. So, oh, and one more. Yes, I've forgotten I put this in. Philosopher Alfred North Whitehead, again, with a sense of humor, said as follows. He says, scientists animated by the purpose of proving that they are purposeless constitute an interesting subject for study. You get that? So scientists who are there are some scientists who are very keen to jump on the bandwagon and say there is no purpose to anything. We'll talk a little bit about who they are in a minute. So they get very animated. I mean, you just need to watch Dawkins or Jerry Coyne or Sam Harris or some of these chevra on the subject, and they get very animated by the purpose of proving that they are purposeless, which itself is quite fascinating. Okay, let's move on to something serious. So who's in the driving seat? And again, tonight we literally are just scratching the surface, but because there's so much discussion around self, mind, brain. Who am I? When I say the word I, what do I mean? Who am I? Can we separate self and consciousness and brain and mind and memory and all this sort of stuff? Monism, dualism, all this sort of stuff. But who is really in the driving seat? So until really, and although we very much do not want to get into the philosophy tonight, that we'll do next week, but it absolutely needs to be appreciated that philosophy, like any other discipline, does not exist in a societal vacuum. And it is not a coincidence. It is not a coincidence that at a time when materialism and reductionism was coming to the fore. What does that mean in the simplest terms? It means when society stops looking at a human being as something more than just a pile of neurons and atoms. Materialism says that this is the sum total of who you are and what you are. It is the material. And reductionism, also a form of that, to say that reduce everything, distill it, drill it down until all you have are the physical properties and all of the processes and all of the things that happen are merely physical. And when we do that, and of course this happened at a particular point and a time in history, then the scene is set for these sort of debates to happen. So, for example, we have Thomas Huxley, famously known as Darwin's bulldog, describing in 1874, he's describing human beings as conscious automata. And he writes, volitions do not enter into the chain of causation. The feeling that we call volition is not the cause of a voluntary act, but the symbol of that state of the brain, which is the immediate cause. And I can supply all the various quotes afterwards. I didn't want to put everything in. So, and we do know, by the way, although this isn't tonight's topic, we very well do know that neuroscience has also helped us to see nowadays that very often when we think we are thinking, we are actually feeling. And that can absolutely be demonstrated when it comes to moral reasoning and, let's say with some of the iterations of the famous trolley car experiment, where it can be demonstrated when you ask people to make, very, very briefly, the famous, would you kill the fat man dilemma. So you have to make a choice between intentionally putting one person in harm's way, who until this point was a bystander, in order to save many people. And 80% or so of people, give or take, this experiment has been done again and again. I think there's even a website, I think it's from Stanford or Yale, where you can actually go and see it. And 80% of people will just say, almost without blinking, and they'll say, yes, of course, the trolley car driver should go down the side track and kill the one guy the railway worker who wasn't until that point in time in danger, in order to save the 5 or the 10 or whatever. But then when you use exactly the same logic and you extend it and you say, well, you're on the bridge, you're a bystander, you also have moral agency, would you push the fat man off the bridge, where as Philippa Foot has demonstrated, it's very, very difficult to point out any real differences. People automatically, they give very different answers. And when they give them these dilemmas, whilst they are subject to functional magnetic resonance imaging, the fMRI, where you can actually see which areas of the brain are lighting up, and you can see whether it's the limbic region or the prefrontal cortex, and you can see that they may think that they are thinking, but we know that they are feeling. And this is a big topic, and it's an important topic for, Yuval Noah Harari has suggested that Tesla in the future, when it builds in with the driverless cars, and it needs to have, you should be able to buy two models: the Tesla egoist or the Tesla altruist. So depending on the algorithm, who would it kill? Would it save you as the owner of the car or the innocent bystanders? And fascinatingly, they've done some research on this, and they've worked out that the same people who say that really it should kill the occupants of the car to save many people who are innocent bystanders, and when the same people are asked which model of the car would you buy, unhesitatingly they buy the Tesla egoist and not the Tesla altruist. So moral reasoning is, of course, incredibly complicated. But having said that, this has set the scene. And when we do the Torah aspect of this in 2 weeks' time, we will refer to this. There's a seminal little piece by Rav Hutner, which we will do on this. So the stage is set. We have, in the late 19th century, we have materialism, we have reductionism. Now, you may say, well, who cares? What difference does it actually make? Surely the reality is the reality. And I have to show you a little bit of research that shows, which is well-accepted research, that this is simply not the case. Here is a quote. There are actually two quotes that go together. If you've seen this before, don't shout out. I mean, don't shout out anyway, because I will give you the answer. But here are two quotes. The first quote is, if a child were not declared alive until 3 days after birth, then all parents could be allowed the choice. Only a few have under the present system. The doctor could allow the child to die if the parents so choose and save a lot of misery and suffering. I believe this view is the only rational, compassionate attitude to have, unquote. That's the first quote. So in other words, 72 hours after parturition, we should reshape the parameters, the legal parameters of what and when somebody is considered to be alive, so that if somebody is going to be a drain emotionally, financially, because they are challenged, disabled, or whatever, then we should just be able to give them an injection and let them slip away. That's quote number one. And quote number two is very, very similar. No newborn infant should be declared human until it has passed certain tests regarding its genetic endowment, and that if it fails these tests, it forfeits the right to live. And the authors of these quotes were Doctors Watson and Crick, respectively, because, and I've got, this is one they wrote this in scientific journals. So this is a very, one can see very clearly the provenance of these quotes. Now, they are not, I'm sure, I have no doubt that they were wonderful fathers and husbands, and have no reason to doubt that. But what I think this demonstrates very clearly is it's not a coincidence that they who gave the world so much by the discovery of the double helix, arguably the greatest discovery in science, which has led to huge advances in medicine, science, and technology of the last century, and for which they rightly became Nobel laureates. But it actually follows, because once you reduce the mystery or the majesty of a human being through reductionism and materialism to a double helix structure of different nucleotides, and you have a G and a C and A and how they combine. If that's all there is, well, then if you're in the laboratory and you do an experiment and it comes out flawed, then it's very simple. You just chuck it away, you put it in the sink, and you start again. And the thinking and the reasoning follows. It's perfectly logical. Once you have reduced a human being from being what we believe is B'Tselem Elokim to being just a bunch of a random mutation, then of course it follows. And so that is an important point. And again, just a small quote, there's much more, but it has been demonstrated that belief in free will itself, and therefore some scientists are now talking about something called illusionism, because they don't want to say that we shouldn't teach people something which is not true. On the other hand, it has been shown that even basic neurocognitive processes change when somebody believes in free will. And moral behavior, here we go, here's just a little bit, there's much more, but in 2002, two psychologists had a simple but brilliant idea. Instead of speculating about what might happen if people lost belief in their capacity to choose, they would run an experiment to find out. Kathleen Vose, then at the University of Utah, Jonathan Schuller at the University of Pittsburgh, asked one group of participants to read a passage arguing that free will was an illusion, and another group to read a passage that was neutral on the topic. They then subjected the members of each group to a variety of temptations and observed their behavior. Would the difference in abstract philosophical beliefs influence people's decisions? And I must add, this is not technically accurate. This is not differences in abstract philosophical beliefs. They have just read those beliefs. It doesn't mean that they have thought them through and have chosen to subscribe to them. All they have done is they have spent 2 or 3 minutes reading a point of view. Yes, indeed. When asked to take a maths test, with cheating made easy, the group primed to see free will as illusory proved more likely to take an illicit peek at the answers. When given an opportunity to steal, to take more money than that was due, than they were due from an envelope of $1 coins, those whose belief in free will had been undermined pilfered more. On a range of measures, Vose told me, she and Schuller found out people who are induced to believe in free will were more likely to behave, people induced to believe that there is no free will are more likely to behave immorally. And there's more, there is more where that came from. But again, all that does is it actually shows us that whether or not there is free will, but the belief in free will, or a belief that there is no free will, very much impacts, it impacts people, it impacts their behaviors. Now let's get down to that fateful lunch in Freiburg in 1964. So what happened was as follows. This is very early days as far as neuroscience is concerned, and the capacity to, there was a very basic way of with the very early computers of being able to study brain waves and brain activity. We could, in response to events. So if a person hears a song or looks at a photograph, then you could look at the brain waves that were generated, but nobody had figured out a way to isolate the signs of somebody's brain actually initiating the action. And so Kornhuber and Decker came up with the following, rather ingenious, actually. They did something rather ingenious. They had to do a form of reverse engineering in order to make this work. They had to, you'll see in a second. So what happened was they got a dozen volunteers, and you can see there's a picture of one woman there. So it looks like one of these old cathode ray things. She's in a metal toll booth, and she wires fixed to her scalp from this shower head like contraption above, and she has one task. Would Madam care to move her finger? She was given. She and a dozen others were given the choice that they could do an activity, should they so wish, up to 500 times a visit. Move your finger at will whenever you want. That was the task. Simple as that. At irregular intervals, you decide whether you want to move your finger and when you want to move your finger. And the results of the experiment came, as you can see there on the left-hand side, in these dotted lines, a representation of changing brainwaves. Now, what happened was, in the milliseconds leading up to the tapping of the finger, the lines showed a uptick. Neurological activity, which is essentially electrical activity, messages sent via and through the nervous system, It's like a wave that rises for about a second, like a drum roll of neurons, and then it ends in an abrupt crash. Now, what did they do with that? We'll see in a second. This flurry of neuronal activity, which they were able to see, they gave it a wonderful name, which we'll come back to a little bit later. And that's pretty much what they did. That's basically all they had did. Now, what did they do? They worked backwards. They had to come up. They had to come up with some ways to circumvent the limits of technology. They had what was then a state-of-the-art computer, but it could only start working once it had detected a finger tap. So what they did is they recorded the brain activity on one tape, and then they played the reels backwards into the computer. That's what they did. Reverse averaging. That's what they did. Now, this was considered to be wonderful, because now we could see, once you played it backwards, you could see what happens in the brain before a person does an action. You can see now the brain activity of the decision-making process. But now, by the way, the Nobel laureate John Eccles and the famous philosopher of science Karl Popper, they praised Kornhuber, and they even compared him to Galileo's use of sliding balls. They thought it was amazing. He basically had a handful of electrodes and a tape recorder. They had done an amazing thing, but it didn't really tell us a whole lot. What did they call it? This wonderful word. And of course, it was Germany. So I think, after being here long enough, I think I can actually pronounce it, and tell me if I'm wrong. And they said what they had discovered by sort of looking back, playing it backwards, they could see the brain activity associated with getting ready to do something, the Bereitschaftspotenzial. And I believe that is correct. But of course, we're English, and therefore we don't have such an exotic word. It's down there on the right-hand side, readiness potential. Or, because we're really lazy, RP, as it's known. So it's RP. So far, so dozy. I mean, there's nothing really has happened so far. All what they've managed to do is they've managed to, we can see now what happens at the brain activity prior to an action happening. Very nice. Doesn't really help me very much. And that was kind of it for about, fast forward 20 years to 1983. And then we discover Benjamin Libet, or for you and me, Benjamin Libitsky, son of Ukrainian Jewish refugees from the Ukraine. So he was in a conversation with others. It's a bit of a longer story. And he actually, by the way, not that it necessarily matters all that much, a little bit like Kornhuber, but not to the same extent. He was not anti-free will in any way, but he started asking the questions. He said, okay, we have a timeline. We can see what happens 500 milliseconds, that's half a second to you and me. There's half a second the neurological activity begins to pick up, and then we have a decision. And then we can see the crest of the wave, but maybe we can dig down a bit deeper and try and work out what happens when and why. Is there a decision? And this is what he discovered, that potentially there is a decision before the decision. And this is where the fun starts. This is where the trouble starts. And this is who he was, a researcher in the physiology department of UCLA, of San Francisco. And he then does, and this has gone down, this is now legend, the Libet Experiment, 1983. Now, let me take you through it. I'll tell you what's been happening here. So what he did was, he said to them as follows. He gave them what is today is already called the Libet. I'm not sure what it's called, Libet or Libe, the Libet clock, which is, you can see that on the right-hand side. Okay. And I believe it rotates. Its rotation, I think, is 2.56 seconds, if I'm not mistaken, or something like that. Doesn't matter. They would look at what is today called the Libet clock. He updated the same experiment, and he asked people. But here he introduced something called W. It's not actually on this particular graph, but it's usually called, when spoken about or you read about it in the literature, it's called W. And that is, he asked people, again, same thing. You decide if you want to move your finger or not. It's entirely up to you. But make a note by looking at my clock exactly the exact moment in time when you decide to move. So we have this Bereitschaftspotential, we have this readiness potential happening. We now have an observer, the person himself, making a careful note of the exact time that they decide to move their finger. And now let's put them all together and let's see what we come up with. And then he realized something pretty amazing. And you can really see it here in the graph. Let's go from left to right. Okay. So from left, you have activity in motor cortex begins. So there's a very clear uptick in neurological activity. And this is almost a third of a second, not quite, before the moment that the person consciously makes a decision. So you have three things going on over there, okay? You have the activity in motor cortex begins, and you can see the graph coming up quite sharply. Then you have, just before the crest, you have awareness of intent to act. It's called, in the scientific literature today, it's called W. And then the finger begins to move, and then it crashes, it peaks and plummets very, very quickly. Now, the problem is, of course, as follows. What do we now have? What we have is that the body, the brain, is sending very clear, significant neurological activity, telling the arm, the finger, get ready to move, guys. We got a job coming up. 300 or 200 milliseconds before the person has made the decision. That is the classic challenge, as it were, the assault on the notion of free will, because it means, really, classic free will thinking would dictate that a person makes a decision and then the brain, then the brain responds. That's why the cartoon before, can you see, this is what it is? This is what we're saying. You've got something else here. You've got the brain seemingly knowing beforehand, and by the way, in neurological terms, that is centuries. In terms, almost half a second is an era in terms of neurological activity. This is the way it was seen. It's seen very much now as a significant challenge to free will. It seems the brain would know before. Now, there is significant medical literature, scientific literature since, which I've trawled through quite a lot of, and this there are various ways that you can say, well, what does this actually tell me? So there are a number of quite eminent scientists who started attacking the methodology of the experimentation. They looked at the precision of that point W. However, again, and I don't even understand all of the literature. I've waded through a lot of it, but I don't understand all of it. But one thing seems to be quite clear, that this was in 1983, he published in 1985, and since then, there has been, it has been replicated by ever increasingly more precise technology, fMRI. And all of this is externally. It has even been done now intracranially, and I'll come to that a little bit later, which is even more precise, to the point of being able to isolate single neurons, which is awesome, absolutely incredible. The guy called Yitzhak Fried in UCLA, assistant professor in UCLA, he's a world leader on this. He's done some incredible stuff. We'll come back to that a little bit later. So, but whichever way you look at it, it seems to be generally accepted that there's something going on over here. Even if you want to challenge various aspects of some of the methodology, it seems to be very clear the brain would appear to know beforehand what you are doing. And that would appear to be a very important and classic challenge on the notion of free will. Now, one of the things that Libet himself put forward as a response to almost to, in his words, to save free will is, I'm not sure whether he called it this or whether it's just some clever guy decided to call it the free won't. And this actually, I'd like you to remember this because I believe there is a Torah aspect to this, which I'm going to come back to in the third lecture. That's why I'm mentioning it now, the free won't. He said, well, it could be, he said, let's even accept perhaps that for some reason, somehow the brain seems to know beforehand what a person is going to do, which is problematic. However, that doesn't mean that we have totally slain, we've killed off free will altogether, because a person would still have the power of veto. And he did some experiments where he told the subjects that occasionally what they could do is they could decide to veto. Even once they decided to act, the Bereitschaftspotenzial was there, the curve was going right up, and then at the last minute, they'd made a decision to act, and then they changed the decision. Do they still retain control? And it seems that they do. This experiment, again, has been redone again and again and again, and it's been refined more, although fascinatingly, in the literature, there is relatively little on it. Only recently, there's been a bit more interest in it. So this is kind of where it had been from sort of 1985, going on till into the 2000s. And then we have this fellow, Yitzhak Fried, who he's done the single neuron studies of the human brain. That's actually the title of his book on Amazon. And he is a world leader in this. What did he discover? He operates on epileptic patients. Now that we generally speaking, we don't allow, from a perspective of medical ethics, we don't allow doctors to just open up people's crania and poke around. But once they are open, especially with epileptic patients, and you do it when they're awake, as is very well known, and he discovered the ability to isolate single neurons or single clusters of neurons, very tiny areas of neurons, where he was able to, listen carefully, intracranially, he was able to provoke a desire to move mechanically, externally. In other words, he was poking around in the brain of an epileptic patient, and the patient said, when you just touched me there, I felt a desire to move. In other words, he had almost externally, through external stimulus, he had touched an area of the brain that is able to create, and he did it externally, manually. The patient observed that when he touched that, not that they moved. It wasn't a reflex. They felt a desire to move their hand or their finger or whatever it was. So again, that would just seem to be taking the challenge perhaps even further. So where does this sort of leave us? So first of all, I mean, the first thing to note, of course, is this is scientists such as Sam Harris or Richard Dawkins. They jump on this with glee, and in a number, you will notice if you read the literature, you will come across a lot of stuff which will appear to say almost as if free will has been debunked. And there's a pushback starting not that long ago. I mean, I can give you some quotes. I'll give you some quotes, for example. Yuval Noah Harari, in his latest book, 21 Lessons for the 21st Century, he speculates that in the age of big data, free will likely be exposed as a myth. And there are others as well. Now, by the way, this raises all sorts of fascinating problems philosophically, accountability for the criminal code, the legal system, and we'll talk about them a little bit next week. But let's move on with the neuroscience. So Libet came up with free won't. He came up with the concept of free won't. And he says, therefore, you've seen that it might be that there are some things which there does seem to be the brain somehow does seem to know beforehand, not too sure exactly how or what, but we've salvaged, we've saved a little bit, he says. We've got this thing called free won't. I do think it's actually significant. I think he's really hit on something very important from a Torah perspective, but I'm going to leave it for the Torah lecture in 2 weeks' time, but let's just remember it. And here we come to what is probably the final point here for us tonight, at least, which is the discovery of somebody called Aaron, I don't know how to pronounce his name, Schurger, Schurger. He's a researcher in the National Institute of Health and Medical Research in Paris. And he discovered something where, a bit like brain, you can call it neural noise, right? Like in weather patterns and in fluctuations in the stock market, there are natural waves. And in neurological activity, they also exist. I've got the exact term here. It is called stochastic fluctuations, I think, or something like that, if I'm not mistaken. It is called, averaging of stochastic fluctuations of neural activity. And it has been observed. And he suggested as follows. He said that perhaps, without challenging in any way the outcome or the credibility or the accuracy of Libet's experiment, but the conclusion that was drawn very possibly suffers from a fatal flaw. And a lot of work is now being done as a result. His work is now considered seminal. This was in 2010, 2012. Just to give you a little bit of an update, if you're interested, the Templeton Foundation, which is quite famous, is in the middle of a $10 million collaboration, and they're putting together something now. They talk about neurophilosophy, and they've just published a 70-page white paper on it. I waded through a bit of it. Absolutely fascinating. The collaboration between philosophers and neuroscientists to see how these things can work together. And this is one of the ways is the following, what I'm about to tell you now. And Schurger suggested as follows. He said he had been studying fluctuations in neuronal activity. It's a sort of spontaneous flickering from hundreds and thousands of interconnected electrons. Now, from a bird's eye view, it just looks like any other sort of noise devoid of pattern. But then he had the idea that if you would line them up, their peaks and their troughs, like thunderstorms in meteorology or the market records for the Dow Jones or something, and then he would reverse average them, then the way it would look visually, it would be like a rising trend. There would not appear to be any purpose to it, but there are definite patterns. And then he had the following idea, which he has since tested. He said, hold on a second. What happens if I apply the same method to the spontaneous brain noise? What would the shape look like? And he did it, and the pattern that emerged from him reverse averaging all this apparently random brain activity, yes, you guessed it. What does it look like? Very, very closely mimicked the Bereitschaftspotential. Hold on a second, thought Aaron. And he has since been joined by numerous others. There's a lot of serious research going on about this. He said, maybe, of course, even if we accept that Libet's experiment was fundamentally correct, but perhaps we have committed a fundamental error in the conclusion. And that is the difference between causality and correlation. There would appear to be, he says, what Libet has proven, that there is correlation. There is a connection of some sort between this Bereitschaftspotential, this readiness potential, and a person's decision and then to act. But that is not necessarily the same thing as saying that one causes the other. Now, is that not semantics? What does it mean? So he says as follows. neuroscientists have known for a long time that when we make decisions, our neurons gather evidence for all the different options that face us. We gather evidence, and there is what they call a decision threshold beyond which we decide to act. Now, this sensory information can come from all sorts of different senses. You know, I look out the window and I see that it is raining, and that is enough to tip my neurons out over the threshold to say I should probably take a coat or an umbrella. Fascinatingly, and we didn't really speak, by the way, about the fact that the choices that Libet were giving the people had no moral connotation at all. If you notice, we didn't even discuss that at all. But that itself provides a difficulty. What's the difficulty? I am a subject. Picture yourself. Think about it. I'm sitting in this booth. They're doing an experiment on me. I know that. And they're asking me to flick my wrist or not flick my wrist, tap my finger or not tap my finger. And I have no external stimuli to help me in making that decision. Where is my threshold? What is it going to be based on? Why should I flick my wrist or not flick my wrist? I can do it whenever I want, if I don't want, and therefore actually the neurological activity and the processes that need to happen in order for me to ultimately decide, the threshold has to be crossed. And I can't even refer to or draw upon external stimuli because there's no blinking reason why I should or why I shouldn't. It's meaningless. But, and this would make perfect sense, when it corresponds with the natural peaks and troughs, when my neurological activity is anyway rising as it does randomly, then I am less distance away from the threshold. It makes perfect sense that when, naturally speaking, my neurological activity is rising anyway, as it always does, randomly, this noise which he has demonstrated exists, it makes perfect sense to say then that would tip me over the threshold and say, okay, I'll move my finger, why not? So there is, of course, this correlation. Of course, there's a connection between the two. That does not, however, demonstrate in any way causation. And they have actually done more work on this and using, in other words, looking at it as a symmetry breaking signal. That's the technical term. They did a study with monkeys, choosing between two equal options. A separate team of researchers saw that a monkey's upcoming choices correlated with its intrinsic brain flow, the brain activity, even before they were presented with the options. And finally, there's a guy called Professor Uri Maz, computational neuroscientist at Chapman University, is involved in a study to take this further and to investigate this further. If you want to look him up and see the stuff that he's doing, absolutely fascinating. But that seems to be where things are moving now. In a new study, which is under review for publication in the Proceedings of National Academy of Sciences, Scherger, together with two other Princeton researchers, they repeated a version of Libit's experiment, and therefore to avoid unintentionally cherry-picking brain noise, they included a control condition in which people didn't move at all. There was an artificial intelligence classifier, allowed them to find at what point brain activity in the two conditions diverged. Now, if Libet was right, that should have happened at 500 milliseconds before the movement with the Bereitschaftspotential. But the algorithm couldn't tell any difference until about 150 milliseconds before the movement, which is the point in time when people reported they made the decision. In other words, people's subjective experience of a decision, what Libet's study seemed to suggest was only an illusion, appears to match the actual moment their brains shows them making a decision. The story's not over, obviously, by any means. But what it does show, and this, I think this is more or less, this is up to 2019 pretty much. And I don't think a huge amount has happened since then. There is a lot of more work that is ongoing. To me, it reveals a number of interesting things. it shows, and I'm going to finish off with, as I said, I would top and tail it with a little bit of humor. We started with Stephen Hawking, and I'm going to finish off with that great sage Dilbert. But the science also does not exist in a vacuum, does not exist in a cultural vacuum, and the glee with which certain philosophers or scientists with a predisposition towards a particular perspective pounce upon something and say that free will is dead. It's just simply not so. And this is the scientific community, nothing even to do with religion, is able to show that there is still plenty to talk about. It's not, the debate is not over by a long shot. So that is just a small foray. Again, like I said, I am certainly not an expert. I don't claim to be an expert, but I shall give the last word here to Dilbert, because as always, he puts it so well. Do you think the chemistry of the brain controls what people do? Of course. Then how can we blame people for their actions? We're going to talk about that next week, because people have free will to do as they choose. Are you saying that free will is not part of the brain? Of course it is, but it's the part of the brain that's out there just kind of being free. So you're saying that the free will part of the brain is exempt from the natural laws of physics? Obviously, otherwise we wouldn't blame people for anything they do. Do you think the free will part of the brain is attached, or does it just float nearby? Shut up. Push a person to the end and see, when you can't deal with it anymore, you just resort to the classic answer. And I suppose what even we as religious Jews, as thinking Jews, should keep ourselves informed with what's going on. It does have implications for us. And next week in Yetz Hashem, we will continue. Part 2 will be philosophy. We'll look at possibly determinism, hard, soft, compatibilism, and various other strange animals. And also we might look at some of the Jewish philosophers. We'll look at more at the moral reasoning and the implications for the legal world as well. And then in the final one, in Yetz Hashem, we will look at some of the Torah. Thank you very much indeed for joining me. I hope you found that useful. And I bid you all a good evening.